Okay, welcome back, colleagues and friends. These are some few questions under introductory analysis course, our introductory analysis course that we have been looking at. Before we start with this, please, if you haven't subscribed to my channel and you are a student of real analysis, or in the case of University of Education, whenever they call it introductory analysis, kindly subscribe to the channel. Thank you in advance. Okay, so we have a question here which says the limit as x approaches infinity of this question. How do we go about this kind of limit? Well, it involves roots, and so this limit we can actually write it as the limit as x approaches infinity of x squared minus 3x minus root of x squared plus 1, like this, all over 1. We know this is over 1. So in our calculus course, you know that we can rationalize from the numerator. So that is what we are going to do here. So by rationalizing from the numerator, we have limit as x approaches infinity of root of x squared minus 3x minus root of x squared plus 1 all over 1 times root of x squared minus 3x plus 1. So this is the conjugate of the top, root of x squared plus 1 all over root of x squared minus 3x plus root of x squared plus 1, like this. So we have this. So we will have the limit as x approaches infinity. This is difference of 2 squared. This one here and this one here are difference of 2 squared. In other words, this term squared and this term squared. Okay, difference of 2 squared, you remember, which is a squared minus b squared equals to a minus b, a plus b. So this is a minus b and this is a plus b because they are the same thing. So we can just constrict the two terms and write it like this. So we will have root of x squared minus 3x all squared minus root of x squared plus 1 all squared all over, this is just 1. So 1 multiplying by the down here, we just have root of x squared minus 3x minus plus root of x squared plus 1, like this. So here we have the limit as x approaches infinity. At the top we have x squared minus 3x minus x squared minus 1. The top to be this, all this over root of x squared minus 3x plus root of x squared plus 1. And so this and this will go, and this will imply that we have the limit as x approaches infinity of negative 3x minus 1 all over root of x squared minus 3x plus root of x squared plus 1. So here we can actually factorize x squared down here out from each root. So this we can write as limit as x approaches infinity negative 3x minus 1 all over root of x squared into brackets 1 minus 3 over x, like this, plus root of x squared outside 1 plus 1 over x squared, like this. You see? So we can do this. So right now this will imply we have limit x approaches infinity, negative 3x minus 1 all over x root of 1 minus 3 over x plus x again root of 1 plus 1 over x squared. Okay, but you know how we take limit to infinity of rational functions like this? We divide each term by the highest power, or the x with the highest power. So this will imply that we have the limit as x approaches infinity, negative 3 over x minus 1 over x all over x root of 1 minus 1 over x 1 over 3 over x, sorry, all over x, okay, plus x root of 1 plus 1 over x squared, all this over x. So this and this will go, this and this will go, and this and this will go. So we will have the limit as x approaches infinity of negative 3 minus 1 over x all over root of 1 minus 3 over x plus 1 plus 1 over x squared. Now, but as x goes to infinity, this will imply that we have negative 3 up. This one will go to 0 as this x become big. Okay, so minus 0 all over root of 1 minus 0 plus root of 1 minus 0, which is equals to negative 3 over root 1. So root 1 plus root 1 is equals to negative 3 over 2. This goes to negative 1.5 as our final answer. Okay, thank you for watching. Kindly subscribe to the channel. So the final answer is negative 1.5.